Question 7. An object with initial temperature 32 degrees is placed in a refrigerator whose temperature is a constant 0 degrees Fahrenheit. An hour later, the temperature of the object is 16 degrees Fahrenheit. What will its temperature be 4 hours after it is placed in the refrigerator? Okay, we know that uppercase T, it is temperature in terms of Fahrenheit because of how many times they say Fahrenheit in these. And lowercase t is time in hours. Okay. So let's decipher a few things that the few bits of information they threw at us. Initial temperature 32 degrees Fahrenheit. That just means that initially, which is when time equals 0, the temperature is 32 degrees. It's placed in a refrigerator whose temperature is a constant 0 degrees Fahrenheit. Okay, the refrigerator, which is the surroundings, is at a constant 0 degrees Fahrenheit. So we know that Tm, which is just the surrounding or the ambient temperature, is 0. Okay, an hour later, the temperature of the object is 16 degrees Fahrenheit. So at T equals 1, or at lowercase t, time equals 1, the temperature is 16. And what will its temperature be 4 hours after its place? So what is T of 4? So when lowercase t equals, or time equals 4, what is temperature? Okay, so we can use Newton's law of cooling, which they so graciously gave us. Shoot. We know that Tm equals 0, so we can just write 0. Okay, well, we should recognize immediately that this is a separable equation, which is great for us, because that means it's much easier to solve. So let's get all the uppercase t's on one side and all the lowercase t's on the other side. We can do that by multiplying everything by dt and dividing everything by 1 minus t minus 0, which is just 1 minus t. So you get dt over t equals negative k dt. Integrate both sides. What we get is natural log of t minus k, or equals negative kt plus c. We can isolate uppercase t by exponentiating both sides. E to the natural log just cancels out, leaving you with t. And then you have e to the negative kt plus c. Okay. When you have two things being added together in the exponent, what you can do is you can just rewrite it as e to the negative kt times e to the c. But since we know that e is a constant and c is a constant, e to the c is just one big constant. So we can rewrite this and find a particular solution, which is t equals c e to the negative kt. Now, we can use our initial conditions to solve for the c value and the k value. Okay, t of 0 is equal to 32. So that means when temperature is 32 degrees Fahrenheit, time is 0. Okay, we know that e to the 0 is just 1, so we know that 32 is equal to c. So our equation is becoming more and more clear. Let's use the second initial condition they gave us, which is t of 1 is equal to 16. Okay, so when temperature is 16 degrees, we know that time is equal to 1 hour. Okay, let's divide both sides by 32, leaving us with 1/2 e to the negative k. We can take the natural log of both sides. leaving us with natural log of 1/2 equals negative k. And k was just equal to negative natural log of 1/2. So the final solution we get is t is equal to 32 e to the natural log of 1/2 t. So what is t for? That means that t is equal to 4. Okay, so t is equal to 32 e4 natural log to 1/2. Remember our natural log rules. If we have a constant multiplier, that can just be rewritten as the power. This is one of the most useful natural log rules. So we can rewrite this as 32 e to the natural log of 1/2 to the 4th. E to the natural log can just be rewritten as, or just can be, gotten rid of. And then now we're left with 32 1/2 to the 4th. 1/2 to the 4th we know is 1 to the 16th. So 32 times 1/16. That just means t of 4 is equal to 2 degrees Fahrenheit. Or no, sorry. Yeah. Which is option B. Very good.